we want to look at another properties, another two essential properties, okay, uh, for inverse and Laplace. The inverse of this over this plus b squared, the inverse of this function is equal to exponential at, because this and these are the same, that will cos bt, That's one properties. Then the next one, another one for inverse of this function, this fraction. Case of you have b over x minus a squared plus b squared. Okay, in this case, this will be equal to exponential at sine bt, or sine bt. So if you look at these two formulas, you realize that if you're going to have exponential with cosine, then you must expect to have the numerator and part of the here, the first part of the denominator being the same, but this one will be squared. Okay, but in the sign, they will not be the same. I mean, this part here and this one here will not be the same. Okay, but it must be x minus a squared. X minus the attachment of your t here. The attachment of t here is a. Okay, minus a. Okay, but also you must also note that whatever you have there, you must have single of that on the numerator. If you have 25 here, which is 5 squared, you must have 5 here. Okay, so that's just that on these two laws. Let's see questions on these aspects. Let's look at the solution to these three questions. Find the inverse of this fraction. They are all fractions, and we have said that inverse and Laplace is for fractions. It's for fractions. Okay. The first one, the Laplace of 10x over x squared plus 16. Inverse of that, inverse of that. The 10 can go outside. Then we have inverse of this over x squared plus 16. Okay. So if you look at this now, in this case now, this will not have, this is just basically 10 cos 40. Okay, cos 40. No, this is 16 is what you have, it must be multiple, b squared. So that will be cos 40. That one is very straightforward. Then the second one, number 2, inverse of what do you call it? X minus 1, inverse of x minus 1, x squared minus 2x plus 5. Okay, so that's what we have here. What we're going to do here, we have to express this form in two parts. Okay, actually, we can't factorize this. Okay, but we can use completing the square method to express this in perfect square. Okay, and this will be x squared minus 2x plus 5 will be equal to x, half of 2x, half of 2 is what? 1. Square that. Okay, whatever you had here, take that out and square that, plus 5. You added 1 here, take it out, square of that, then plus 1, plus 5. And that will be equal to what? X minus 1, minus 1 squared plus 5, that's plus 4. So we now have inverse of x minus 1 all over x minus, this one is a square, x minus 1 squared plus 4. So we have expressed this, the denominator in perfect square, okay, which now conform to this law, and that will be equal to a minus your, in this case now x minus 1. The a here in this case now is 1, so that's t, and then cos what? Cos. This is 4. That is 2 squared, 2t. So that's that on that question, and that's what we look at it. Look at it. Okay, so that will be exponential at, then cos one of this bt. Okay, then the third one, the third part of this question, the third part, we have the Laplace inverse of x minus 3 over x squared minus 2x plus 5. Okay, what we are going to do, if you know this one, we just did it not quite long. This one is what? X minus 1 squared plus 4. Okay, so, and it's not equal to x minus 1 here, x minus 3. And normally for the standard rule, for the standard rules, they must be equal. So what we are going to do now is to break this into two parts. X minus 1 minus 2 all over x minus 1 plus 4. You can close this so we can achieve our targets. Okay, then you now split that. You now split this expression, and that will be what? That will be inverse of this over x minus 1 plus 4. Close this. Then minus 2 inverse of x minus 1 squared plus 4. Just break into two parts. Split into two parts. Okay, x minus 1 over this, then plus minus 2 over this. Okay, and that will give you, this one is a direct, that will be et cos 2t. Then minus, these two can come outside. Okay, these two can come outside. We have to do some manipulation here. 2. Okay, no need. This is 4. We have half of that up there. Okay, that's okay. This is 2 squared. This 2. So that will be equal to et sine 2t. Et sine 2t. So that's that on that question. Another property which I can call, I call it 2 now? Yeah. Another property we should know, inverse of n factorial over x minus a n plus 1. Inverse of this will be equal to, we have the inverse of that, that will be equal to exponential at t what? Tn. Yeah, inverse of n factorial x minus a n plus 1 is this. So that's another properties under this inverse. Inverse of this fraction, inverse of this that fraction, inverse of 5 over x plus 2 power 4. So what we can do, can the 5 go outside? That will be 5 Laplace inverse Laplace of inverse of this x plus 2 power 4. This will be 1 power 4. Okay, so something is mixing there. You know, ideally, if you're having let's say you're having 1 over x x4, as we did in the other question, we expect 3 here for you to have x4. So so something is missing here, so we have to put that back there. So, and that will be 3 factorial. So we expect here, we expect 3 factorial here. So that will be equal to 5 inverse of this. This will be 3 factorial brought in over x plus 2 power 4. And then this 3 factorial introduced there will be removed outside, 3 factorial. Okay, so and that will be equal to exponential here is plus, and the standard rule is this. The standard rule is inverse of n factorial over x minus a n plus 1 is equal to what? Tn. Okay, so if you are having plus now, like we did here, that means we are having, our answer will be equal to what? 5 over 5 factorial. Okay, exponential e minus 2t, and then t what? T3. T3. Okay, T3. How did I know? You must be aware that if we know that Laplace of T3 is what? A 3 factorial over what? X4. Okay? And if you take inverse of this, you get what? You get this function back. Okay? You get that function back. So finally, that will be equal to this 3 factorial, not 5 factorial. This is 3 factorial. This will be 5 over 3 factorial is a 6 e minus 2t. This. So that's that on that question. Then we go to question 2. Question 2. You just have to do some little manipulation by bringing in 3 factorial here. Okay, introduce that and cancel that again outside. Okay, so that it will not alter the question. Okay, then the second one, we have inverse of 2x plus 18 all over x squared plus 25. What we are going to do here, since we're having x squared here and we're having 2x here, we are going to separate this expression, which will be inverse of 2x over what? X squared plus 25. Then plus inverse of what? 18 over x squared plus 25. Okay? And don't forget, normal algebra, if you have 2x plus 18 over x squared plus 25 is the same as this. It's the same as x squared plus 25. Okay, then plus 18 over x squared plus 25. Same thing. Okay? So then this one will now become, these two can go outside. The two can go outside. This is 25. Then you have 2 times, this will be what? Cos what? Cos 5t. And then this one, the 18 can also come outside. Then you have 18 inverse of, you have 5 here. So if you have 5 here, you have 5 squared here, then we are expecting 5 here. Okay, over x squared plus 25. Okay, but this 5 wasn't in the question. It's not in the question. Okay, so we brought it there. So we have to cancel that outside. And so our answer will be what? 2 cos 5t plus 18 over 5 sine 5t. Sine 5t. Inverse of 6x minus 4 all over x squared plus 4x minus 20. Okay, first thing first is for us to express this. Can we factorize this? Can we? 20, 4 and 5, 10 and 2. We can factorize it, but we can turn it to perfect square. And that will be equal to what? X, take one of this. Then minus is here. Half of 4 is what? Is 2. Square that. Then whatever you added 2 here, take that outside and square that. Then plus what? Minus what? Is it minus or plus? Sorry, this one is plus here. So plus 4 here. So plus is here. Okay? So minus 2, yeah, is plus 20. That's plus 20. So as I was saying, plus 20. Yeah. So express this as a perfect square, which will be you take one of this, take half of this, okay, square that. Then whatever you added here, remove that and square that. Plus what? Plus 20. And that is what? X plus 2 squared. And that's what? Plus 16. Okay, so we now have this will now become inverse of 6x minus 4 all over what? All over x plus 2 squared plus 16. Okay, so that's one way. So what we can do now, we can separate that if you want to. You can separate that. But the best option is for us to make it this way. 6. Anywhere you see this one, put x plus 2 there. X plus 2 all over x plus 2 all square. Okay, plus 16 here. Okay, let's now do some algebra here. This one times this one, 6x. This one times this one, plus what? Plus 12. Okay, and we have minus what? Minus 4 here. So we've added more than that. So how can we get how can we get a minus 4 back? Well, so that will not alter the question. Okay, so then we are going to do what? Minus 16. Minus 16. Because 12 minus 16 will give us our minus 4 back. Okay, so that's one way we can solve that. Yeah, that's one way we can solve that. Yeah, that's one way we can solve that. So, and then we can now split the inverse now. We can split that, and that will go to inverse of 6x plus 2 all over x plus 2 squared plus 16. Then minus 16 inverse of 1 over x plus 2 squared plus 16. Okay, and if you don't like to do that, you can, it's 16 here, or minus, just separate that in that way. Okay, so that will now become, this one is the direct answer. Yeah, this will be 6, this will be 6 cos, this will be 6 e minus 2t cos 40. Okay, then this one, we have to make some adjustment. Since this 16 could be 4 times 4, because 16 is there, so we expect to have 4 here. So we can take 4 outside. 16 here is 4 times 4, so we can take 4 outside. So minus 4 inverse here, and then 4 here also, x plus 2 all squared plus 16. So that's what we have there, and then that will give us a final answer for that. 6e2t cos 40, then minus 4 e minus 2t sine what? Sine 40. Sine 40. Okay, so that's that. You are just playing with this this identity here, and that's that. So that means if you have plus here, this will become minus here. Okay.